So what do you think it would be? A, isn't it? It's the ability of a material to be stretched into a wire. I think when you read through the other answers, some of these, and this is how you get good at questions, isn't it, when the multiple choices, some of them are just, you can change it and swap it. It's not going to be that. But the ability of a material to be stretched into a wire just seems to fit, doesn't it? I think it's pretty obvious what ductility really means, isn't it? Are you happy with that, Alex?
Yeah.
Yeah. Okay, let's have a look at that one. So, relating to drawings, really, and what we do in an office. So, you're working in a drawing office, you're presented with a drawing showing scaled dimensions of an installation and the location positions of the equipment. So, what type of drawing do you think it is?
Layout.
It is a layout, but why would you say a layout when you look at what's on there?
Because it's on about locations of things. That's
right. It's not just dimensions, it's showing you where they are. So it's showing you the position of that. If you look at the others, it doesn't really, does it? A circuit, when you look at your circuit drawings, one part of that drawing might be 30 foot away, but it'll show it condensed because that's the next thing in line. That's how I understand it. So, yeah, a layout shows you them positions. That one, a report into a material used for manufacturing a part describes malleability requirements. Which statement best describes malleability?
D.
No, I won't put that.
I was going to say C or D.
Well, weirdly, it's B.
Is it?
Yeah, the material
I would have said D as well.
Without significant plastic deformation.
I've always been taught that the malleability means you can bend something without it breaking.
Let me flip my other document up, unless I've wrote this down wrong on here.
I thought it was C.
Yeah, I've wrote it down wrong. I do apologise. It's C. I'm challenging myself then, thinking, go on then, Pat, why have you put that? Yeah, you need to absorb energy, plasticity, and it deform without fracturing. So in other words, you can stretch it and move it. Think of Stretch Armstrong. Fantastic malleability. I don't suppose you ever had one of them when you were kids. I'm sure Ian did. You used to have it's like a bloke, about 6 inches, 7 inches high, and you could stretch it the length of your room. Quite spectacular, really. But yeah, the ability to have a material to absorb energy and plastically deform without fracturing. Okay. I'm back up on here. So, next one. A machine at work is suspected to be out of tolerance. What's the meaning of tolerance? What is a tolerance?
Working with maggot.
The what, sorry?
Working with maggot.
No. Do not think electrically minded, people. You think back to when you were in training centre.
Oh, no, B.
It's B, isn't it? It's a range of sizes within which a component is acceptable. Okay.
It was always out of tolerance at training centre.
But when you think about it, if it's related to a machine suspected to be out of tolerance, well, that tolerance would be range of sizes within which a component is acceptable. And when we also think of tolerance, don't forget we used to file plus or minus 0.2 of a millimetre.
Yeah.
So you've got an upper range, a lower range. So it depends how it's described with tolerance. Okay. An investigation into a breakdown on a machine has revealed a bearing has failed. Which of these is a cause of failure with bearings?
Right. I can remember when we got sent the things for this question, and this popped up on it, and I can remember reading it. But last time I checked, all of them could cause a bearing to fail.
Right. Okay.
Is it dirt?
What you're looking at really is cause and effect, aren't you? So if you said D, so an investigation revealed the bearing has failed. Which of these is a cause of the failure? Well, seizure, that is the failure, isn't it? So that's the effect. But what caused it to seize? What causes it to vibrate? So realistically, what you're looking at is you're looking at wear.
Right.
So you're saying that the bearing has actually worn away or is wearing away. Now, that is sort of, how can you put it? That is the failure. So that is the effect. The cause can be any of the others. If you get dirt in it, it could cause the bearing to fail. It could cause it to seize, to vibrate. So the wear, to me, is the best answer on there. It's not a fantastically worded question with its answers. But can you see what I'm getting at?
Yeah.
If I was to put dirt, would I still be right?
No, I don't think you would. No.
Because see, when I first read it,
I think I still put where.
if the machine, for whatever reason, maybe it's been knocked or whatever, starts vibrating, then that could knock it out, and that could cause it to fail. Date could cause it to fail, and then if it's just worn down over time, it could cause it to fail. That's what I thought when I read it, so I was a bit like, it could be any.
Yeah, well, I was the same, and then when I looked through it again, I thought it was where.
I mean, you can say where, but like if it's a brand new bearing, it can still fail and seize if there's dirt in it.
Yeah.
There's an argument for all three.
There is
Yeah.
really, isn't there? Yeah. Well, you got me there, guys. No.
It's such a relative question. Depends how you've
It
been
is, isn't it?
taught,
Like I say,
how you look at situations.
the answers are crap, really, but it is what it is. If that's a question that comes up, cause of failure with these bearings. Yeah, it could be dirt, it could be wear. Subjective. Sorry, fellas, that hasn't helped you at all, has it? I mean, it's only asking for one answer, isn't it? So.
Well, it says which of these, so maybe it's asking for more than one.
When you sat your test doing, do you get a chance to click on more than one answer on any?
No, there's just one.
Right.
I think, from what I can remember.
Yeah, it was one, I'm pretty sure.
Well,
I put way down for it, I'm pretty sure, but that was just because it's usually, I was going to say it's the most common, but then if the machine's not looked after, date could be the most common. Just depends
Depends what the quality of site you're on.
yeah, if you get dirt to get into bearings goes into the grease, doesn't it? Or the greases are overheated and perished, and you get dirt into it. So, there's a lot of other factors can go into saying dirt. But yeah, I sort of get it. Well, it could be wear or dirt, gents. I shall try and get clarification of that for you. A little bit miffed with that one. Yeah, the more I discuss it with you, I can see the point. Thought I had that one covered. But hey, obviously not. Let's try another one. Let's move on. So, after using a hydraulic lifting device to raise plant and machinery, what must you do before continuing with your diagnostic procedures?
B.
Yeah, it's B, isn't it?
Yeah.
Insert suitable support equipment such as axle stands or other suitable rigid stands which have been inspected. So, you know, it's all right lifting something up. You've got to make sure it doesn't move. You know, even now I've lifted gearboxes up onto benches, and as you slide them forward, it pushes the lifting device backwards, so you risk it tipping off the bench. You know, little things like that. You've got to make sure that they can't fall. So in that instance, yeah, axle stands or suitable rigid stands, something that's been inspected as well. Don't just wedge a bit of pipe under it or a bit of plate.
Yeah.
You know, it needs to be a proper job that have been inspected and stamped to say, yeah, it's capable of doing this. Everyone happy with that one? Pretty straightforward.
Yeah.
Well, next one's about viscosity of oil, isn't it? So you've been asked to service a machine which includes an oil change. The machine is known to run at high temperatures, so you want to investigate the effect of heat on the viscosity of oil. So what happens to the viscosity of the oil as the temperature increases?
Viscosity decreases.
It does, that's right. So basically what we're saying is all oils have a level of viscosity. And that tends to be let's be honest, it tends to be the thickness of it, doesn't it? The thinness, the thickness, whatever we want to describe. But basically, usually the thinner the oil, the higher the temperature. You don't need, if something's running very slow and it's very heavy, you don't need thin oil, because thin oil would just squeeze out and you'd end up creating a lot of friction and a lot of heat. So heavy things tend to have heavy oils or greases instead. If you think about a massive water wheel, the weight that would be sat on a water wheel, you wouldn't put thin motor oil on it, would you? So yes, as soon as you get heat into those oils, they stop being effective. And basically the viscosity of it, they tend to, as the heat gets to them, they tend to thicken up, and that's because all the polymers and different things and additives that have been put into that oil to make it special, which is why it costs so much, they start to burn off. They can even oxidize, and all sorts of things can happen to them. And yes, the viscosity of the oil decreases, it gets thicker, becomes less effective, and then you start having pressures. I know you've all got cars and things like that, but you obviously, one thing you know you get taught or people mention to you, advice passed down, is don't put the wrong viscosity of oil into your car.
Yeah.
If I look in my handbook, it tells me use this specific oil. You know, 10W5, whatever it is. It used to always be 1040, and it's all about the thickness. Okay. Boring subject, but there's two different standards for it as well. There's sort of a world standard, and then you get the bloody Americans deciding, the automotive industry, that they can have their own standard. That's why you get two numbers. Okay, everyone happy with viscosity?
Yes.
Good.
Yes, all right.
While consulting a specification sheet for a static engineering system, you come across the abbreviation UDL. What do you think UDL stands for? Whoops.
C.
Think again.
Would it be B?
I think it's B, uniformly dynamic load.
Question.
It's an unidentified distributed load. I don't think that's something that you would term, is it? It's like unidentified. It's a spread load.
What does uniformly mean?
Uniformly dynamic load, I suppose uniform. If you think of uniform, it's standard. It's a certain size. It's a, you know, if it was non-uniform, you would tend to think of something of a very strange shape that would be unbalanced. If we took a block of steel that was a foot square and put two little lifting hooks in the corners, it'd lift up perfectly, wouldn't it? Because it's uniformly. So I think that's what that means. But it's a uniformly dynamic load. We wouldn't necessarily have it distributed, but it's dynamic. All items of plant, including mobile cranes and hoist, need regular functional tests. So when completing the test on site, what must you be aware of?
C.
Oh, excuse me.
The safety officer.
Oh.
Is that so you
The
could
movement
quickly
of
do stuff
deliveries
you're
and the
supposed
safety
to?
officer. No. The movement of vehicles and pedestrians. If you think of a crane,
I like that answer.
you're going to have a lot of space out there, aren't you? And basically, people test them. You don't want the public wandering in or customers parking the car in the car park and coming wandering over. So if you were conducting that test, you would have to have a roped off area or coned, and then, and have that in place. I'm looking at my answers. Ian, are you still on?
Yeah, I'm just in the back. I just got a call, but I'm back.
All right, mate. I'm looking at some of the questions, that John sent through.
Yeah.
Because I got about 15 minutes on this morning. And there's a couple on his sheet, I must say, are actually wrong. So just be careful.
Yeah, on that sheet that John sent through, I think his answers are, there's about 3 or 4 of them I disagree with.
Yeah, and I've gone down this and sort of clicked ABC. So that one there, I'm thinking about that again. I do apologise again, gents. I've only looked at this for 10 minutes this morning. But
uniform distributed load.
It's the top one. It's A.
Yeah.
It's not B. I'm talking rubbish. It's A.
A load that is distributed or spread across the whole region of an element, such as a beam or a slab.
There you go. You should be doing this, Ian. Not me. I'm trusting this to me.
I should have put the notes in the bottom for you, shouldn't I?
You should, yes, you swine. So there's some of them questions. I don't know if I've helped or hindered you now.
You know that last one, Pat?
Yeah.
Could you argue a point for A? Because obviously fumes is something else you've got to look out for.
The thing with it is, when you think of that and you're doing a test on site and what to be aware of, if you handled risk into things, ultimately, wherever you do that crane test, you're going to have fumes going everywhere, aren't you, once the crane starts up. However, the movement of vehicles and pedestrians, that is your main risk. If you imagine a vehicle driving right through and you're testing a crane, which means you've probably strung it onto a test load, and if you imagine a car driving under it and it dropping on them, they won't be very impressed. And the same with, pedestrians walking through. So I think fumes is something that you would be aware of, and I'm sure if you were setting the test up, you'd try and factor it in. You'd move it as far away down the car park as you can away from offices and people, but sometimes you just can't do that. So I suppose fumes would be on your risk assessment, but it wouldn't be as high as vehicles and pedestrians. They're your main issues.
Yeah.
Some of these questions, I think they've not really written very fairly. I would have made that the movement of vehicles, pedestrians, and maybe included fumes in there. If you're in an overhead crane, I think where Owen's coming from, if you're out on plant somewhere, they've got an overhead crane, let's say, for instance, down at the Boss plant. If they're tipping sulphur in the steel, there's going to be sulphur fumes. But we're talking about a functional test of a crane here now, or a hoist.
Well, that's the difference, isn't it? It's not using it on the job, it's doing that test.
This is an normal offload test. So the obvious answer would be for vehicles and pedestrians. You'd be checking the area, because as Pat said, there would be a test load on the crane. So if you've ever been in a mill or anything where they use the electromagnet cranes, moving big heavy lumps of steel about, you can drive lorries straight in there for loading and what have you. And obviously there are people walking around on the ground instructing the crane driver what to do, so that's your two main hazards.
Yeah. I've worked at a few quite big companies, and I know obviously British Steel's a big company, Jacobs are a big company now with all the sorts of stuff they do. I worked alongside Jacobs on some aviation stuff a few years ago, so I know what they get involved with. But a lot of companies now are actually going away from owning their own plant equipment. If you imagine in years gone by, you would buy an item of plant like a crane, you would invest in it, you'd put capital investiture to it. So your company would say, okay, that crane costs £1 million. We're going to utilise it, and this is the reason why. These are the cost savings. This is what it'll take, and it'll probably take us 10 years to receive, to break even on it. But £100,000 a year is what we're spending on cranes. Now that used to be the attitude, which was great, because then industry would buy all these bits of equipment. Now, I don't know how many sites you've worked with, the people you've worked with, but a lot of the smaller stuff, not the really, some of the really big stuff, yeah, some, like you say, in the hangars and what have you, you've got. But a lot of stuff now you just hire in for that use. And that's what your site managers do, and plan it with your site engineers. And you would plan a lift and you would say, we only need that crane for 2 days. Now the cost might be £10,000 a day, but it's still cheaper. And the other side of it's not just the fact that it's cheaper. What people don't factor into it is all the time, energy and money spent testing it, making sure that the quality of it's correct, etc. Slings, chains, links, insurance, all that comes as a cost. So a lot of plant equipment now on site is only hired from companies, and then all that responsibility of checking it and testing it is on them. And it's a massive thing. They even have coded entry and coded use now. You put a number in and you don't need a key. If you don't know the number, you aren't going to get it to work. And then it logs how long you've used the piece of equipment for. It's brilliant what they can do now. So a lot of testing is what I'm saying, is actually going out. They don't do as much as what they used to do. Do you hire all your plant in, Owen, or is it fixed where you are at that place?
No, they hire stuff in for cranes and that.
Yeah, I know a lot of it goes on, and also you often hire. Obviously, you hire the driver, but you can, a lot of places you will hire a crane lift supervisor who will plan the lift for you, and it's a really important area because it does knock the insurance down on your site, your management. It's a big sort of thing in the back office, but hey ho, yeah. So there's some of the questions that Ian threw in, which is great. What I'm going to do is I shall share another document, hopefully. That's the right one. Which one's come up? Does that one come up?
Yeah.
Mm-hmm.
Yeah. Let's see if I can shuffle you all back on there. Make that a bit bigger for you. So these are off the initial test, obviously. Look, you can see that. So I'm going to share a few more. We'll discuss them as we go through if you want. It's just some of them we've already done, obviously. Some of them we haven't. So we've done those two. We've discussed about them. Data sheet for printed circuit board refers to conductivity. So you obviously know about electrical conductivity, Alex. That ain't a problem. We said about malleability. We said about tolerance, and we know what tolerance is, upper and lower. That one we got confused on. I'll get some clarification.
So can we get a definite answer for that one?
Is there what? Sorry?
Can we get a definite answer for that one? That bearing question.
Well, wear can be subject to vibration or dirt, can't it?
You can make an argument for A, B, and C, not D, obviously, but
A, B, and D are all symptoms of C.
Yeah, that's what I thought as well. That C, is the outcome really. Those are the symptoms. That's the outcome. So the failure of it, the fact it's worn. Why did it wear? Well, the symptom could have been vibration, dirt, or seizure. So I would stick with where, gents, and if I ever manage to find that answer out better, I shall instantly let you know. But seriously, that's what I'd go with. Have a look at
Where's
another
the
one.
answer they're expecting?
Yeah. So this sort of stuff you might pick up on. So the company that you work for has decided to adopt the TPM strategy for maintaining plant and equipment. TPM is an abbreviation for Total Productive Maintenance. It's important that we have that. It's not precautionary. It's not preemptive. We're not really striking Iraq, are we? But there is preventative maintenance as well. Now they've put down their total productive maintenance. I can't hear you, Owen.
No, that's Alex. His mic's locked.
Right. So, Owen, from your side then, do you think it's total productive maintenance?
Well, it's in bold, so I'm guessing that's the right answer. I probably would have probably said D.
If you Google it, it comes up total productive maintenance, but I always thought it was total preventative maintenance.
Yeah, I would have said D, to be honest.
This is it. These are where we said these questions Ian needed a bit of work on, and I think we discussed it before, didn't we? It's total preventative maintenance, gents.
But the answer that they're looking for is total productive maintenance.
Yes.
Oh, it's the actual answer is D.
No, the correct answer is B. But if you Google TPM, it will come up as total productive maintenance.
Yeah, it will. So just try and remember that, guys. It's productive. We would say preventative. I would teach that, but stick with productive. Apparently, it's what their answer is. Not that we're telling you what their answers are. That'd be cheating. Okay, you're required to check current. You should know this one. Yeah, you're going to use a multimeter. One of the others that Ian has in his hand. He often checks himself with his multimeter, does Ian?
Don't leave out without it, does he?
Portable electrical generation equipment has the potential to cause serious injury and is covered by the Electric at Work regs. The regulations state that the equipment, it says that, is maintained in a safe condition. Now, people argued on a different session I was on, and one thing, when we're talking about PAT testing, it has to be done every 6 months. Let's just be clear on that. PAT testing doesn't have to be done every 6 months. That's not what it's asking.
Discretion of the owner, isn't it?
Yeah,
it is. Or of the product. Sometimes the product will give you guidance of how long it needs to, the space or time for a portable test to be done.
It can depend what it's being used for as well.
Yeah, but it's basically telling you that it is maintained and it's in a safe condition. That's what it's saying that you should do. And that law there, 89, it's not been amended since, and there's been no other notes put to it, to the best of my knowledge. So it can be a little bit thin, guys. So go for the obvious. It's maintained. It's in a safe condition. Okay. You wouldn't want to replace everything every 2 years. It'd cost you a bloody fortune. You imagine a fan or something simple in an office. Well, you're not going to check that and throw it away every 2 years, are you?
No.
Okay, as long as it's safe and it's maintained. So, as the health and safety officer in a local engineering company, an increased number of accidents and incidents leads you to believe that employees are unaware of signage around the plant. You decide to update and make all staff aware of the differences in signage. What are the intrinsic features of prohibition signs? Well, it's got there, red and round. You know what a no entry sign looks like, don't you? Think of your road signs? The red, the round, they're telling you not to do something. It's prohibited. You will not do. You want to ban smoking? You put a picture of a fag and a red ring and a line through it, don't you? So, however, let's think of some of the others then. So what are the others? What's yellow and triangle are saying to you?
Warning.
That's right. It's a warning. If you something as simple as yellow, if you imagine in a shop, they've washed the floor or done it in your office or workshop, they put a yellow triangle down, don't they, or a yellow board at least telling you. What about blue and round?
Is it a recommendation?
Recommendations. So if you think of where my drilling machines are, there's lots of blue signs up in there telling you to put your eyeglasses on, you must wear PPE, blah, 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 blah. And what about green and square? What the green ones tend to be?
Mandatory? They're just like information.
In effect, it's information. It's showing you the way. If you think of a fire exit, it's green, isn't it? Running man, it's telling you where to go. It's a health and safety feature, an escape route. So green and square is giving you information that you need in the event of an accident or wherever it may be. Good. So look at this. Health and safety officer at local engineering company been asked to observe a new engineering work activity using a range of tools and equipment. You need to ascertain the PPE needed in order to carry out this safely. You'll also need to assess the hazard risks that might be involved, and you identify a number of hazards. So ultimately, what constitutes a hazard? Well, simple, isn't it? A hazard is anything that may cause harm. You know, I suppose if you think at a hazard is an unplanned event that did not result in injury, illness or damage, but had the potential to do so, what would that be?
The word's on tip of me tongue.
Near miss.
Near miss. Anything that has the potential to do anything of that maybe it happens. Yeah, the potential is the word I'm looking for there. So yeah, fair enough. Hazard. Well, it might not have resulted in any of that, but it could have done. You know, and I always described it when I used to talk to the fitters that when you talk about the potential to do harm, you know, it's also the potential of the person who's maybe directing something. So, for instance, a pencil might not be dangerous, but if you go stick it in an electrical socket, it is. So you can never plan for idiots, but a lot of companies, a lot of people everywhere tend not to report near misses. And the fact is quite simple. A near miss, if you imagine a near miss could be a one-off and it's never going to happen again. Nothing happened. Brilliant. Okay, that's fine, you know. Pat walked out of his house on a sunny day, stood in the middle of his garden, looked up and got struck by lightning. Well, the chances of that happening are so slim, fair enough. You know, it happened one day, it hit the shed, Pat shat himself, and yeah, we better put everything, every time we go out, we better do a risk assessment, especially if it's sunny. Now, you wouldn't, but you'd be amazed how many potential accidents and near misses occur of exactly the same thing in the same spot. And those are the ones that eventually catch somebody out and do either damage, result in injury, illness, or kill somebody. And you would be amazed how many times things don't get reported, and then everybody goes, oh, that happened to me last week. Bloody hell, I saw Clive do that on Tuesday. Fucking hell. Well, you need to report them, and it's important. And companies under health and safety law are supposed to have that. So anything to do with potential hazard, you spot something and think, you know, it's one of them where you hold your head and go, Jesus, did that just happen? You lucky sod. No, you might have been a lucky sod, but tomorrow your mate might happen exactly the same and he'll get got. So you got to be careful. I'm a big believer in reporting near misses. I've worked with health and safety over the years, and you'll be astounded how many times an accident occurs and then everyone comes through when it's investigated and said, oh yeah, we're aware of that, or yeah, that happened before but it was okay. Anyway, I'll stop babbling. All items at plant, including mobile cranes and hoists, we discussed this one out. It's obviously the movement, it's not obvious, but it is the movement of vehicles and pedestrians. They're the main things. Okay, so upon completion of a diagnostic test, an intermittent fault was found on a safety system of an item of plant equipment. What action would you take? Well, there it is, B. you wouldn't just make a note of it and return it to the customer. You know, if it has the potential to really do harm, then you would not do that, would you? You take your car in because it's making a noise, the wheel's making a really bad noise, and you sort of go, well, yeah, it's making a noise, isn't it? And give me it back. You would tell somebody what it was, but you would take it out of service and say, no, it's too dangerous for you to drive. We're going to have to fix it, and this is what's needed. So take it out of service, isolate it, and tell your supervisor. And even as young engineers, you need to be confident in that. Okay, so you're working on the plant, and you see one of the chains, how can we put it? Yeah, one of the chain links looks a bit damaged, a bit bent. You've seen it go past a few times, and you think, yeah, hang on, here it comes again, yeah. Are you not going to bother telling anyone, we only changed that last week, it'll last a bit longer? You're not. You're going to go and tell your supervisor, but if you just wander off and spend half an hour trying to find your supervisor, the chances are there could be an accident in that half an hour because the chain came off and landed on someone's head. So what you've got to do is basically take it out of service, and that's having the confidence, guys, to say to the operators, gents, stop it now. There's a fault. We need to isolate it. I'm going to lock it off. I'm going to talk to my supervisor. We'll get people here as soon as possible. And obviously, we don't know all production up, but we've got to be safe. Have the confidence to do it, fellas. It's not nice when you might get someone screaming at you, but it needs to be done. Otherwise, you'll just ignore the near miss or the potential for a serious accident. All right.
If you just smack this emergency stop button, it just stops everything. You still
Right.
go wrong.
Okay. Well, I know you don't necessarily want to do that, but if you saw something like that and that's what you're doing, at least you know what to do. That's the main thing, isn't it? Taking harm away from everybody. Explain it later. Okay, so the next one. Health and safety officer at local engineering company. You've been asked by managers to ensure that the company conforms to 14001 standard. What is it? What is that standard? We all hear about these standards, but what is it?
Environment.
Yeah, so it's down there. It's a standard specifies requirements for an effective management system. And basically, this effective environmental management system, it's a framework that your organisation follows. And basically, rather than establishing environment performance requirements, it states in there what you need to do. It's a plan. And in that plan, it'll cover things like storage, what to do if you have a spillage or a leak, contamination, if it needs to be fireproofed, etc., etc. And there's a lot of stuff that goes into an environmental management system. I wrote one myself up at AMEC, and I thought it was going to take about 20 pages. No, it doesn't. Once you get into it, it's incredible what one of them can actually cover off, the potential for it. If you just take a simple thing as a little generator, diesel generator you're going to use on site, and you've got to put fuel with it. So you've got to carry diesel, you've got to carry enough to keep you going for 24 hours. It's on a call out. So how do you store that in your van? What happens if it leaks? Where are you going to put the piece of kit on site? What do you have to take with you? So it's actually incredible what it leads into. Everyone happy with those?
Yeah.
Yeah, cool. Have a look at that one. Following successful completion of a service, you're asked to dispose of the removed fluids from the plant equipment. These must be disposed of in line with which of the following acts? Well, we got it down off the last one, really, didn't we? Environmental Protection Act 1990. Contaminated oil used to be an horrendous thing. People never knew what to do with it. They'd keep it in great big vats. They'd tip it out in general. They'd pour it into the soil, not realising it's going to be there for the next hundreds of years. And it is our Environmental Protection Act. And to be honest with you, I remember when that was altered, because it was something else before that. You can see in there, Pollution Act and bits and bobs they try and say. They were all linked into one. But this Environmental Protection Act I thought was brilliant when it came out, because it stopped people from tipping shit anywhere. It stops you from setting fires to tyres. Ian will remember that. You used to get bloody tyre fires everywhere because nobody could dispose of them. I still can't
seriously bad ones
understand.
as well.
There's what? Sorry.
There were some seriously bad ones as well.
There really was. I know it's a joke on The Simpsons, but a tyre fire will burn for an unbelievable amount of time, and the crap it pips off is unbelievable. I'm not sure now if they have to shred them. I know they were going to look at shredding them and putting them in with road surfacing stuff like tarmac and what have you to give you more grip for your cars. I think it's a great idea, but I don't know where it's taken off. So yeah, Environmental Protection Act. Don't know what's happened there, but I've locked up. You still there, guys? Yeah?
Yep.
Yeah.
Okay. Rival companies been found guilty of not adhering to specific environmental standards. What's the consequence of it? Well, fines and loss of reputation. It is unbelievable now what the courts can do. The courts changed about 8 years ago, I think it was. And basically, these fines and loss of reputation are unbelievable. If you had a serious environmental leak, or you just did something, you didn't comply with something, non-compliance, you would find that HSE would completely investigate it. They would be published. They would get sent out as alerts. And what happens is, if you say you had an oil spillage and you were a bit blasé about it, they would actually use it as a toolbox talk and send it to every company that the HSE knows. So it'd be a case of, oh yeah, British Steel just disposed of a big vat of oil out the back of so-and-so and we found it's leaked into a river. Well, at one stage, people didn't used to give a damn. It was like, all right, well, give us a bit of a fine. I think an environmental fine was up to £2,000. They'd say, well, go on, fine us £2,000. It's cheaper than getting rid of the oil in the first place. Now, I'm not saying British Steel would do that, so they wouldn't. But
No,
the
that.
consequences now are unbelievable. The fine is unlimited. And if you're a big company and you show profit, as most companies do, in the millions, you will get fined millions. And I say that tool alert will go around everywhere. Everyone will get a toolbox shout, and you will be embarrassed. And that reputation now is everything. British Steel has to have a squeaky reputation now, no matter what we think. And they put things in place for that, especially in view of they want customers to come back, customers to come with you. It's very competitive out there. Okay. As a maintenance engineer for a large company, you've decided on a maintenance strategy for the plant you oversee. You've identified critical items of equipment and decide on a preventative maintenance strategy for these assets. One of the main advantages of preventative maintenance is less risk factor because the equipment is being regularly checked, ensuring that there are less risks to break down without notice. When it comes to preventative maintenance, this is where maintenance scheduling comes in. Now, when you think about it, if we are scheduled to go and check on one of Rich's milling machines, we're supposed to go on it every 3 months and give a few checks, make sure everything's in tolerance, make sure everything's happy. I don't know, you check the coolant for him, check the oils, check everything's in place. It's preventative. And it'll give you a list of things that you're supposed to do. And hopefully in that 3-month period, nothing will have happened. You won't have had a breakdown. If there is anything that needs replacing, you'll be able to see it. And basically, there's less risk factor. Now, some companies argue that that is a very expensive way of doing things. But if you're on a big plant or you're working for a decent sized company, you tend to have a maintenance crew, don't you? And that maintenance crew are doing this all the time. So what they'll do is they'll have this regular checks. They'll have a maintenance schedule, but obviously, if my drilling machine breaks down, the first thing they'll do is they'll jump on that drilling machine and try and fix it. That's fine. It means you can break out. So they're constantly employed. They're not sort of sat around all the time going, next one in until 3 months, lads, get the cards out. I think now it's a mixture of preventative, but also reactive. So you're going to go and fix something as it happens, as it breaks. But just remember that preventative, in theory, there's less risk factor. Preventative is brilliant if you're working in a factory and you're producing lots of components, or like in the food industry or something like that. The last thing you want is that line to come and break. So that's what we do. Owen, are you involved with obviously I know you're doing maintenance and what have you, but I presume that you have maintenance strategies in place as well as, jumping on, fixing stuff.
Yeah, there is a lot of preventive stuff there, but it's mainly reactive when things break.
Yeah, on a lot of busy sites, it can be like that. I know where I was, I know I always harp on about it, but where I was in aerospace, we had a group. We used to have electrical maintenance and fitting maintenance, mechanical maintenance. And it's just the way it used to work, but it did work very well. They had maintenance schedules to work to, and then anything happened, like you say, you'd jump on it and you'd work together and you'd fix it. But hey ho. Alex, are you all right with all this?
Yeah, I'm all right with it.
Cool. A broken piece of equipment then has been identified. You decided to opt the 6-point approach to diagnosing the problem. Select the correct order for the 6-point approach to fault finding. Now, obviously it's there. It's difficult to remember all these guys, even if you know all about diagnosing fault. But I think you need to look in the other questions, answers, and see if there's anything in there that just don't fit. So for me, collect evidence, analyse evidence, locate the fault, determination and removal of cause, rectification of fault, check the system, equipment and the plant. So that is that 6-point. If you look in the others, firstly, do they all have 6 things in? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 in one of them. It's not 6, is it? 1, 2, 3, 4, 5, 6, 7. There's 8 in another one. 1, 2, 3, 4, 5, 6. So the first thing you need to check is the 6. All right, so do a bit of a process of elimination. But yes, in theory, you're going to collect the evidence. Someone's going to tell you this is what is wrong. Then you go analyse it and go, well, that points all to that bush there. Determination and removal of the cause. Well, you're going to look at it, basically. You're going to determine, is that the cause? And if it is, take it out. Then you need to rectify it, fix it, check it again, and put it back into place. Now, just for my benefit, obviously, you're both very aware of locking something off and lock-off procedures, aren't you? I presume you are, Alex, on all your electrical stuff, aren't you?
Yeah.
So before any of that starts, lock it off. You might, and I know it sounds stupid, but I know someone who went to a machine, everyone told them that it was broken, it was mechanical, went to it, looked at the back of it, wasn't locked off, and he got an electric shock. I don't know what happened. I don't know what electrocuted him. I don't know what he did, but it wouldn't have happened if it had been locked off. So, most plant people have got it sort of instilled into them now. Turn up on the job to check something. Right, prove to me it's turned off. Who's locked it off? Right, well, I'm adding to that. And that's another thing to remember. Add your lock to something if you're working it as well. And then even if the other person takes it off, you still know it's locked off. Very obviously, you know the procedure, guys. I won't bang on about it. I know Ian will have covered it brilliantly with you anyway. So you trace the fault back to a circuit breaker that's not tripped out. What is the purpose of a circuit breaker? So it's saying there overcurrent protection. Now this is one Owen, really. You needed to know, isn't it?
Yeah, we covered this one last week. I didn't know it, but I didn't know.
So, you've been asked to perform some preventative maintenance on a machine that involves grease and lubricants. Who has responsibility of providing you with the right PPE? Well, all right, it's the employer. Of course it is. What I would say there is, there's nothing wrong with you asking to see or checking a data sheet. The amount of times I've seen it where someone says, oh yeah, I've got to wear protective gloves, and they come back wearing something that's porous, like a leather glove or gauntlet or something like that, and you think, so just check. You need to still know that you've got the right PPE on. So obviously check a data sheet, even if someone said, oh yeah, we've used that all the time, here's the right mask, check it. I worked with people, believe it or not, who were working with some Sunstrom nose bag masks. You know, these ones that cover your nose and they've got two big circles on the side?
Yeah.
Absolutely brilliant they were. He was working away, grinding stuff. There was paint there, aluminium dust, paint dust, which is cancerous in that industry, all sorts of stuff. And I walked up, watched him for a minute or two. I thought, hey, he's got all his gear on, proper, you know, full goggles. He's got that on. He's got his mask on. Brilliant. He's taped his sleeves up, everything. And then I looked and I thought, he hasn't actually got any filters in it. He never had any dust or particle filters screwed into the ends of them little circles. So just remember that if someone gives you a face mask like that, make sure that you've got the inserts that go in it. You'd be amazed how many people don't, and you think, Jesus. Just check, make sure it has got them in. Don't just trust someone else. Okay. Lifting device we covered, didn't we? Said we were going to block it, make sure that it can't move once we've got something there. Following a risk assessment, prior to performing a routine activity, you deduce that it may be possible to remove a potential hazard from the vicinity of the activity completely. This is better known as, it's elimination. Okay. Now, risk assessment, when you used to go to health and safety meetings, risk assessment was a major thing. Ian will know this from training centres. You had to have a risk assessment covering everything. You could never generalise anything. No, you couldn't say the fitting workshop's dangerous because there's lots of things you can drop and lots of things you can stick in your fingers or your hands or your eyes. You had to literally do every little thing. It used to easily, for a section like Ian's on electrical, he could write 200 risk assessments, all sorts of things. Well, what happens now, and this came in probably only about 10 years ago, you'd turn up, you'd have your book, you'd go to your meeting, your section, you'd open your book and you'd have all these risk assessments, loads of them, rafts of them. And someone would actually say to you, can you actually eliminate that task? Why are you actually doing it? Why are you using that guillotine and cutting pieces of metal 6x6? Why don't you just order 6x6 pieces of metal from that manufacturer? Why do you need a guillotine? So all these questions started getting asked in companies, and now elimination is a massive part of a risk assessment. Can we do this a different way? You know? Why do we need chemicals? Get it chemically treated before we start. So you'd be amazed how different it is compared to when me and Ian were on our tools and everything was risk assessed to the 8th degree. And if it wasn't, to be honest with you, you were working in a very dangerous environment. I know a lot of that used to go on as well. Hey-ho. Supervisor has requested you write an SMP for a bearing replacement. What does it stand for? Well, it's a standard maintenance procedure. I don't know whether they would ask you to write that out, if I'm truthful. I think the supervisor would know. Say again?
I already wrote for you before a job out there.
Did you? You've got a lazy supervisor then. I can understand why they'd ask you to do it, but a lot of the time it's done for you. But yes, that is what it stands for.
Yeah, that's what I said. That they are done before the job for you, aren't they?
Yeah, most of them will be done for you, especially as an apprentice, because they wouldn't want you to miss something for a start. I know you're trusted on site, you guys, and you're coming towards the end of your time. I get all that, but still, one of you didn't write out a standard maintenance procedure correctly, and someone went and used it, or you used it, and someone got hurt. In theory, on the check back, I'd be like, why is he writing that? Now, I'm not saying you'd specifically get in trouble, but somebody would. It's one of them things, isn't it? So if you do write one, get it checked by your supervision, is what I'm saying there. Okay, plant senior technician has asked you to design an SMP for a recurring problem. In what order will you carry out the following tasks? Well, You can't allocate the job to people, can you, without identifying it? So to start with there, you could suggest B and D. So, okay, so you're going to identify it. The answer, obviously, is identify it, analyse it, and take preventative action. In the other one, it's saying, well, plan the task. Well, you can't, can you? You need to analyse it first. We've all agreed on that. Okay, so it comes down to B. A lot of this is, on the mechanical side, is a bit of common sense and savvy, isn't it? Okay. Sparky question. You've been asked to test electric motors, characteristics for its current drain and therefore its power. The motor is rated 110 with a current of 20. Calculate the motor's powers in watts. Well, what did you do? You times it. There you go. You know all about that, Owen?
Yeah, I do now. Must say Ian talk about.
Oh, well, I know Ian covered it off, didn't he? So, good up. Again, a circuit has a capacitor connected to a smooth current fluctuations. Part of the maintenance checks, it's going to be measured. What unit would be used to measure? It's in farads. Now, I'm not going to get into whether you could do denominations of the other three. It's not my bag, but yeah, it's farads.
They're all just fractions of a farad.
That's what I mean. So you wouldn't necessarily put a fraction of you'd use your main denominator, wouldn't you? So it would be farads, but
the standard SI unit is the farad.
Yeah. Okay, as part of completing the daily task list, a maintenance op is filling in a report on electric motor. The report requires the operative to represent a single phase voltage in polar form. What does it mean? Well, show value and related angle. Now, I'll be honest with you guys, it means nothing to me. That Ian will be giggling. He knows it doesn't mean anything to me. He knows, you know, I consider electricians a bit of a plug licking exercise, which means don't let me near it, because I might plug lick it. So if you want to explain that, Ian, feel free, or if the guys are all right, we can move on.
We covered that one last week, didn't we?
Right. Yeah.
Okay.
We draw voltage and current, and depending on power factor is the angle between the voltage and the current. If it's inductive, it's lagging. If it's capacitive, it's leading.
Right. Cool.
So,
are you all right with that, Owen?
Yeah, a little bit, yeah. I mean, it didn't really make much sense to me, but
it's just two lines with an angle between.
Yeah.
So, what's the answer? Yeah, you would show the values and the angle between them. So the angle of one line would be voltage, the other line would be current, and the angle in between, which we call theta, is the relationship between voltage and current.
right.
A bit of an unfair question, that one.
Yeah.
Hopefully I don't get that one.
A maintenance schedule requires a power control circuit to be tested with the power off. When this test is completed, why must the capacitor be earthed? Well, even I know this one. Yes, you've got to discharge any voltage in it. Now, I don't know whether this is true. Ian can laugh at me or not, but I was always told with an old television set, probably a new one, I don't know, but an old one for definite, you could unplug it, but you wouldn't really want to go sticking your fingers in the back of it.
Absolutely not.
Because you would take a good crack off it, and I'm sure many people did. So I suppose, is that the same thing, Ian?
It's exactly the same. It's a cathode ray tube in the old TVs. The main cathode voltage was anything up to 40,000 volts, and it would store the electricity as a potential on the plate.
Right.
Very much like a capacitor. So unless you discharged it, you could get quite a crack off it.
Yeah. So how would you have discharged it in the back of a TV then, Ian?
It was quite often everything was mounted on a metal framework which was earthed.
Right.
So you'd stick a long screwdriver in the cap and actually short it across to the metalwork.
All right. Bloody hell. Not an exact science then.
Now, you'd find old TVs, you'd find the arcing point where it had been done quite often when you took the back off.
Okay, then let's move on. Whilst consulting a specific sheet for a static engineering system, you come across the abbreviation UDL. What's UDL stand for? Uniformly distributed load.
Thankfully, of the 4 answers there, it's the only one that actually makes any sense.
Yeah.
Uniformly developed load? Unidentified distributed load? Yeah.
Well, it was B until I changed my mind and read the right answers on my sheet, Ian. So,
Yeah.
Sorry, guys. Okay, you've been asked to service a machine. This is about the viscosity. We talked about viscosity. Yeah.
Is that decaf?
And that's it. That's all my questions.
Yeah.
Woohoo! I hear you all yell. That was wonderful. Alex and Ollie, Owen, did you manage to look at the booklet that I shared in the presentation?